All right. Well, hello, everybody. This probably seems kind of strange because you're listening to me on the video, but I'm probably at the same time walking around the room watching what you're doing. But anyway, the few lessons that we do this very last week of school, that sounds nice, doesn't it? But anyway, the very few lessons we do will probably be done via video for math. And that's just because I have the furniture set up in such a weird manner for testing. All right, anyway, let's get started. All right, so we're going to be working on lesson 20. So I'm going to try to be clear as we go through what I'm expecting on each page as I grade. So let's start with the family letter, page 419. And here's what I'd like you to write. I'd like you to just make like a little bracket here and write the word application beside this section here. That's exactly what we're going to be working on, application. I think application is one of the most important parts of math. I mean, why else would we learn it, right? And application on percents is quite practical. It's really important that people know how to work with percents. Several of these we've already worked on. The only thing I don't think we've talked about much is commission, so we might do something about that a little bit later. And you've done a couple of independent assignments on simple interest. All right, let's move on. All right. If you look at the bottom of page 419, on this section called Another Way, I'd like you to underline this sentence right here. It says receiving a 15% discount is the same as paying 85% of the original price. Right now, I'm hoping that makes sense to you. Right, so if you look at this, a 15% discount is 15% off. And if that's the case, then you're still paying 85% of the price. Note that 85 and 15 equal 100, right? So remember the total is 100%. So if you're paying 100% of something, that means you're paying all of it. But if you have 15% off that 100%, you're still left with 85. This becomes very, very useful when talking about sales. All right, look at this. We're going to skip page 420. All right, well, and so I'd like everyone to take a look at this problem on page 421. All right, so let me read it for you. All right, follow along with me. It says last year, a middle school band had 80 students. This year, the band has 120% of that number of students. How many students are in the band this year? All right, so first question I ask myself is this more or less? All right, in this case, see, I've underlined more. Well, that's because 120% is more than 100, so it's more than the total. All right, let's flip over to page 422. All right, let's look at number one, and here's where we'll do the work. All right, so you can see I've got a calculator here. I do not expect you to write any of the calculator stuff, right, but I would like you to write this under number one. Right, the question we are asking ourselves is, what is 120% of 80? Right, and the way we've been doing that in the calculator is changing the percent to a decimal, so that becomes 1.2. Remember, of means to multiply, right, and then we're multiplying by 80, so 1.2 times 80 gives you 96, right, so the correct answer is 96 students, right, and that should make sense if you're thinking about it. There are other ways we could have done this mentally, and we'll talk more about that later, but I bet some of you could have done this in your head. All right, if you can, don't worry about it, right? That's what calculators are for, right? All right, let's move along to number two. I'd like to start here where it says percents are used. And of course, I'd like you to underline the things that I have underlined, and I'd like you to write this in too when we get there. All right, so right here it says percents are used in calculating simple interest. You can owe interest on a loan or earn interest on a bank account or investment. All right, so I'd like you to underline those two things, right? In terms of interest rates, if you're borrowing money, you're going to have to pay interest. But if you're putting money in a bank account or you're making some sort of investment, you're going to earn interest. All right, underline this as well, the simple interest formula. So the formula is I equals PRT. I'm hoping that you are already a little bit familiar with that. All right, one thing I like here is the way they define the words. I know from Ducksters, some people were having some trouble with that. So let's pay attention to this right here. It says the amount of interest, I, is based on the principal, P, the interest rate, R, and the time you borrow or invest the money for, T. The principal is the starting amount. All right, now that right there is a really good definition for principal. It's just the starting amount. What did you borrow? What did you put in the bank account? All right. The rate is written as a decimal. I'd like you to put a little arrow after rate there or down somewhere on the paper. What we're talking about is a percent rate. We just are going to change it to a decimal, but please know the rate is the percent rate. All right, and then this last sentence, for simple interest, time is measured in years. So underline that as well. All right, moving ahead. All right, let's look at A and B now. So it says, suppose you borrow $300 at a yearly or annual simple interest rate of 3.4% for 3 years. What values would you use for P, R, and T? All right, so I'd like you to write this. You don't have to write this part in parentheses. Same down here. You don't need to write that part in parentheses. But I'd really like us to get down what we would put into the formula. So P stands for principal. So in this case, that's the 300. Rate, 3.4%, but note we are making this into a decimal. So we move the decimal point to the left 2. So 0.034. And then since it's 3 years, T is 3. All right, let's look at B. All right, so the principal in this case is 400 because that's what we're borrowing. Interest rate, 3%. So moving the decimal point back 2 gives us 0.03. All right, and here's the tricky part for this one. It's 3 months. So people might be tempted to put a 3 here, but oops, this is 3 months. All right, you got to pay attention to the details. So here's how I figured that out. I just made it into a fraction, 3 over 12, because there's 3 months out of 12 here, and 12 months in a year, and that reduced to 1/4, which gave me 0.25. All right, so be careful about that. All right, so there's A and B. All right, let's look at C and D now. All right, so letter C says, a markdown decreases the cost of an item. That should make sense if you think about it. Decrease, down. A markup increases the cost, right? Up, increases, right? Pretty easy. Suppose a store puts an item on sale for 25% off. Is that an example of a markup or a markdown? All right, so markdown, of course, since it is 25% off. Letter D. Often when you buy something, you pay a percent of the price as a tax. Suppose you pay a 7% tax on an item. What percent of the price of the item will you pay? All right, well, it's the same. 7% tax means you pay 7% of the price. And generally, you're paying that to the government. All right, sales tax is paid, for example, to the state of Maine. That's how it is. How it is. All right, folks, let's look at letter E and the reflect. All right, so this is a little bit about commission here. All right, but let's start here. Many people give tips or gratuities for good service. All right, we've talked a lot about that, so I don't think we need to go there. But this one, many salespeople earn commission on their sales. All right, so real quickly, commission is how companies get their salespeople to sell more. So what they'll do is they'll pay a percent commission on your sales. So the more sales, the more money you make. So then you'll sell more stuff for the company. All right, so that's how it works. All right, so Jason here earns a 9% commission on a $1,000 sale. The question is, how much is Jason's commission? All right, well, what we need to figure out then is what is 9% of 1,000? All right, so I did it here in the calculator, right? 0.09 times 1,000, and I got 90. But there is another way to think about this. I know that 9% of 100 is 9, right? Just think about that for a second. Oh yeah, right, percents out of 100. So 9% of 100 would be 9. 100 times 10 gives me 1,000, so I could just take the 9 times 10 and immediately get to 90. I'm hoping some of you are really able to kind of think that through in your head, because if you have something simple like that, you don't even need a calculator to figure that out. All right, let's look at the reflect. All right, here we go. Is it possible for a single price change to be both a markup and a markdown? Explain your thinking. So you can see I have it right here. Yes, an item can be on sale, so that is the markdown. Then tax must still be paid, so that's the markup. Happens almost every time you buy something. All right, let's take a look here at page 423. Right, what I'd like you to do right now is pause the video, and I'd like you to write each of these things into the graphic organizer on page 423. All right, so pause right now and get that into this graphic organizer. All right, hopefully you have that all in. All right, let's now look at number 2 at the bottom of page 423. Isabel says that 0.02 can be expressed as 20%. Is she correct? Explain why or why not. All right, and the answer is no. And that's really because 0.02 is 2%. All right, she was describing it as 20%, but she wasn't keeping in count that you really need to move 2 decimal places. All right, so hopefully that makes sense to everybody. All right, let's turn over to page 424, and I'll tell you right now, you do not need to write all of this. In fact, the only thing you really need to write is this equation right here that I'm circling with the cursor. All right, let's read the problem though. It says last year, a rapper performed 40 times. This year, the rapper performs 125% of that number of times. How many times does the rapper perform this year? And show your work. All right, so the answer here should be greater than 40, right? Because it's 125%. That's higher than 100. So you can see in my calculator, I just figured out 125% of 40 and got 50. All right, it changed the percent to a decimal and multiplied. All right, now just listen to me as I go through this and see if this makes sense to you. Here's another option. Think about 125% as 100% or all of it, plus 25% more. And 25% is 1/4 of something. Okay, so in this case, the 100% is the 40 times, and the 25% is the 10 times. Okay, so just keep in mind, 25% is 1/4 of something, and 1/4 of 40 is 10, or 40 divided by 4 is 10. All right, hopefully that makes sense. And then you just add those two things up, the 40 plus the 10, and it gives you 50. Note that's the same answer. All right, and again, I'm hoping people are really getting this, because being able to do this in your head is very helpful, because a lot of times you do have to think about percents on your feet. All right, we're moving along to session 2, page 425, and this is finding simple interest. All right, so I'm going to start by reading the problem. Dario borrows $12,000 to buy a car. He borrows the money at a yearly or annual simple interest rate of 4.2%. How much more interest will Dario owe if he borrows the money for 5 years instead of 1 year? All right, so let's use the formula. All right, so right here, here's the formula. Interest is equal to principal times rate times time. I'd like you to write steps 1, 2, and 3. All right, so interest is equal to the principal, 12,000, times the rate times the time. So for 1 year, I got $504. All right, step 2, note that the principal and the rates stay the same. The only thing that changes is the time. So I got 2,520 for 5 years. And then last step, subtract. Your difference is 2016. All right, we are going to end here for this first recording. Awesome job.